Hello again, my friends. Mean absolute deviation. We've got a scorcher for you. The temperatures right here. We are talking about summer. Summer is getting warmer and warmer. 80 degrees, 87 degrees, 89 degrees, 94 degrees, 96, 98. We dip off a little bit to 89 and 91, but we are having a beach day. Look at this. This is perfect. I love it. You can see a little heart in the sand. Isn't that nice? All right. So I want to find the mean absolute deviation of the temperatures here. See if the temperatures are consistent, so to speak. First word you see right here is the word mean. Guess what we're going to find? The mean. You add them up and you divide by how many numbers there are. Before we do that, let's get an estimate here. 80 plus 90 is 170 plus another 90 or so. That's 260 plus another 90, 350. This would be 440. You could even say 450. We'll round that to 100. 550. That's 640. And that's about 730. So I'm going to call it 700. Well, we get 8 numbers here, 730. What goes in evenly? 720 would be good. 720 divided by 8 is 90 degrees. We should get an estimate. We should get an answer that's near 90 degrees. That kind of makes sense when you think about it. The lowest number we see here is 80. The highest number is 98. Wouldn't 90 degrees kind of fit right in there? Let's see what we get. 80 degrees plus 87. That's 167 degrees. I like to add these up one by one, so that way I don't make a mistake. Now, of course, as I'm doing this, you should be doing it too. Pause the video, see if you can do the math here. See if you can make sense of it. Alright, so I added them all up. I get 724. And we said that was right in line with our estimate. If you recall, 720 to 730. We're going to divide that by 8 because there are 8 numbers in our data set. I end up with 90.5 degrees Fahrenheit. We said our estimate was 90 degrees, so that's very, very close. I'm going to delete all this work here so we can get a better picture. We figured out the mean. That's all set. That's 90.5 degrees Fahrenheit. Once I figured out the mean, I need to worry about this next word, absolute. So absolute, if you remember, that's the distance something is from 0, the absolute value. So in this case, absolute is going to mean the distance the numbers are from the mean. So how far is 80 from 90.5? Well, we could subtract to get that. 90.5 minus 80. It's 10.5 away. This number here, 87, that's 3.5 away. You could do the math out. This right here is 1.5 away, right? And then this one, it's going to go backwards. It's going to go the other way. So we got to take away 90.5 from here. And of course, you can annex a 0 on 94 right here. And if you do this out, that becomes a 3. This becomes a 10. That's 5. Line up the decimals. 3 minus 0 is 3. So that's 3.5. I'll speed through, and you can figure these out for the rest, for your own sake going forward. If you want to pause the video and see what you get. So now that I found the absolute value that each number is essentially from 90.5, I'm going to add all these numbers up, and again we're going to divide by how many numbers there are. The deviation, if you say something deviates, that means it's changing, it's different. So what we're looking for here is how much are these numbers deviating, how far are they away from the mean. Now in this instance, I just added all these numbers up the short way. Again, I think that it's easier to add them up one by one in terms of not making a silly mistake. And I know you want to rush through and finish this, but you know, it's not worth it, that extra minute that you could spend getting the right answer rather than trying to take a shortcut. But I took a shortcut, so if you're really confident in your addition, take a shortcut. 34, we're going to divide this by 8 since we found the difference of these numbers from 90.5 and there was 8 numbers there. So we do 34 divided by 8. So the mean absolute deviation here is 4.25. What this number means, that's a pretty small mean absolute deviation. It means that these numbers are, on average, they're only 4 away from the mean. So even though we had a number like 98 that was pretty far from 90.5, or a number like 80, on average, the numbers are actually only 4 degrees or 4.25 degrees away, and that's because of numbers like 91 and 89 here that are really close to 90.5. To give you a better idea of what mean absolute deviation is, let's take a look at the same set of data here. And let's say you were on vacation, and then you came back from vacation, and I don't know, the temperature was 21 degrees. It was freezing cold out, right? So now we're going to find the same information, except remember on the last slide we had 91 degrees. So we've just changed the mean just a little bit. And if you remember when we add these up, we ended up with, well, let's see, 90.5 times 8. What was that? 720. And then I think it was 724. Yeah, that sounds right. 724 was our sum. And so we just lowered it by 70 degrees. So 724 minus 70. I'll explain how I got this in just a second. I just got to get the number out there out of my head before I forget it. 724 minus 70. 4 minus 0 is 4, and then 72 minus 7 is 65. So we get 654 is the total of these. And how I got that number, maybe you remembered that the sum of these numbers was 724. But what I did is I took that 90.5, which is our mean, and I multiplied it by 8. And I knew that that was the sum of the numbers. So I did that multiplication just in my head. What we have here, 654, is the sum. So we're going to divide that by 8. And for the sake of the drill, I'm just going to round this number right here to 82, because 8 almost goes into 14 two times. I know it doesn't, it goes in once. But you'll get a number that makes 81.6 or 7 or something like that. That makes the number round up. So I'm going to round it up to 82 just to make it easy here. And I'm just trying to make a point about mean absolute deviation. So means is 82. So this number right here, this is 2 away from the mean. This number is 7 away from the mean. Or I'm sorry, 5 away from the mean. Let me erase that. This number is 7 away from the mean. This number is 12 away from the mean. This is 14 away from the mean. This is 16 away from the mean. This is 7 away. And then this one's actually 61 away from the mean. This is what we would call an outlier, right? So we would add these numbers up. 2 plus 5 is 7. Plus 7 is 14. Plus 12 is 26. Plus 14 is 40. Plus 16 is 56. Plus 7 is 63. Plus another 61. That's 124. And we're going to divide that by 8, of course. So that goes in once. We get 44 for the number down here. And so that's going to go in 8 times. And I'm sorry, 5 times. I keep doing math too quick here. And that's going to leave us with 4 left over. And we're going to bring down a 0. And so we get 15.5, right? So the numbers on average are 15.5 away from the mean here. And if you remember from the last one, these numbers were only 4.25. So you would say that these temperatures are fluctuating like crazy. And you'd be right, I guess, in some regards. But really, what we had was just one radically different temperature, an outlier. But hopefully you understand mean absolute deviation. It's a way of describing the spread of the data as opposed to describing how the central of the data is, the central tendency. This is a measure of variation. And a measure of variation just basically says how far apart are your numbers. And this number right here is pulling things very far apart. In this example, we were pretty much in summer. Every temperature was pretty close to the other temperatures. Hopefully that makes sense.